Hello, and thank you for joining us once again. We'll wrap up our last couple of examples discussing the intersections of planes and intersections of planes with lines. So one more example of each. So let's say that we have a line with this equation and we have a plane with that equation. If we want to show that L1 is parallel to the plane, we have to think about what's happening. Always think of the reasoning first, then work through a solution approach. All right, so for example, if I know I'm parallel to the plane, I know I'm perpendicular to the normal. So I might look at this and say, hey, what is the directionality that I have? So x minus 3 over 4 for the line in the x direction is 1. 4 minus y, I know that that's not written the way I would like for it to be. I need it to be y minus 4. And if I factor out a negative, that gives me a negative 2 for the y directionality. And then z minus 1 I know is over an implied 1, so the directionality of the line L1 is 4, negative 2, 1. So I know if I'm going to be parallel to the plane, I'm perpendicular to the normal, which means that I need to show, all right, that 4, negative 2, 1 dotted with the normal 1, 1, negative 2, I need to show that that's equal to 0. All right, I can't state it's 0. I need to do the work and the result should be 0. If you do the work and you don't get 0, you know you've made a mistake. All right, so for the dot product, 4 times 1, all right, then I have negative 2 times 1, and I have 1 times negative 2, and that product is 0, so therefore I know I'm parallel to the plane. All right, now line L2 passes through a point and is perpendicular to the plane as well. So I know my directionality of L2, and I want to determine the coordinates of the point of intersection between L2 and the plane. This idea of finding a perpendicular to the plane is going to come in handy when we start talking about distances between points and distances between lines and distances between planes and such things in our lessons to come. So for part B, we know that line L2 would have a vector equation. We have the point 3, 4, 1, right, plus some directionality, lambda is not being used, and that directionality is going to be perpendicular to the plane, so it's going to be in the same direction as the normal. Okay, so how do I find the intersections? Well, I need to take the parametrized form of the line and substitute into the plane. So my plane equation, x plus y minus 2z, so 3 plus lambda, right, plus 4 plus lambda, minus 2 times 1 minus 2 lambda, that must be equal to 1. If I distribute and gather terms, that's 3 plus lambda plus 4 plus lambda minus 2 plus 4 lambda. All of that must be equal to 1. So 1 lambda, 2 lambda, 4 lambda. So 6 lambda must be equal to 3 plus 4, that's 7, minus 2, that's 5. So that's going to be 6 lambda must be equal to negative 4. And if 6 lambda is equal to negative 4, then I can figure out the particular, I can figure out my particular piece that works through. And let's see here, this would give me a lambda equals negative 2/3, or negative 4/6. So my point of intersection, I know the x coordinate is going to be 3 plus lambda, so 3 minus 2/3, so that's 9/3 minus 2/3, so that's going to be 7/3. And then my y coordinate is going to be 4 plus lambda, so 4 minus 2/3, so 12 minus 2/3, that's going to be 10/3. And lastly, my z coordinate is going to be 1 minus 2 lambda. So that's going to be 1 plus 4/3, and 1 plus 4/3 would be 7/3. So the coordinates of that point of intersection, right, are going to be 7/3, 10/3, 7/3. And I should be able to work without a calculator without much trouble. So once again, think of the reasoning, work through that reasoning, then get to your solution approach. Okay. Lastly, here we have a plane, 3 planes defined by a system of equations, and I want to determine the equation of the line of intersection between the planes. So I know I have a line of intersection, so I don't need to go through and try and figure out anything with the determinant. So if I look at my equations, I should see that with equation 1 and equation 2, I can eliminate my y variable, right? And let's see what that gives me. So essentially, if I say equation 2 minus equation 1, that's going to give me 3x minus x, that's 2x. Negative 5y minus 5y is 0y. Negative z minus 3z is negative 4z. And 0 minus 10 is negative 10. Okay. Then, if I consider looking to eliminate another one of my variables, if I look to consider to eliminate another one of my variables or look to substitute, I can work through that in a variety of ways. All right, so that would be essentially the start to your elimination or your substitution method. So let's think here. All right, I have equation 1 minus equation 2. Okay, so that gives me, right, a 0 on the y's. What could I do to get a 0 on my x's? Well, I could say equation, let's say here, if I do equation 3 minus equation 1, right, x minus x, that's going to be 0x. Y minus negative 5y, that's going to be negative, or positive, excuse me, 6y. Right, negative 3z minus 3z, that's going to be minus 6z. Negative 8 minus 10, that's going to be negative 18. So you might say, well, that's really not gotten me too far. Well, could I eliminate y in a different way using other variables? Or could I eliminate x in a different way using other equations? Let's see. I might go and say what can get me to eliminate y once again or to eliminate x once again. That might help me out to do my substitution. But if you're not comfortable with that, that's okay, because you can also always come through and do your approach, the matrix approach. Right? You can set up with the matrix approach if you would like. Okay, and that matrix approach would just be saying 1, negative 5, 3, 10, right? 3, negative 5, negative 1, 0, and 1, 1, negative 3, negative 8. All right. If I'm going to do row reduction with those items, I could come and say, okay, well, I like that I have a 1 in this first spot, so I could just say that's going to stay with R1. I can say, hey, in row 3, I'm going to go row 3 minus row 1. And in row 2, let's go ahead and say that I will have row 2 minus 3 row 1. So row 1 was 1, negative 5, 3, and 10. Row 3 minus row 1, 1 minus 1, that's 0. Negative, or row 3 minus row 1, 1 minus 1, that's 0. 1 minus negative 6, that's 6. Negative 3 minus 3, that's negative 6. Negative 8 minus 10, that's negative 18. So you see that we've really just done that step that we have. But if we're more systematic, we can be more efficient in our solving. If I look to row 2 minus 3 row 1, so 3 minus 3, that's going to be 0. If I look at row 2 minus 3 row 1, so if I do times 3, that's going to be negative 15. Negative 5 minus negative 15 will be positive 10. Right? And then if I say row 2 minus 3 times this, that's going to give me a negative 10 there. And if I look to this equation, this minus 3 times that, that's going to give me negative 30. And then look at what has happened, right? These two rows are a multiple of each other. So that means that eventually one of them can get to 0, right? So if I take this and I rewrite, that's going to give me 1, negative 5, 3, and 10. 0, divide by 10, divide by 10, divide by 10. And then I'm going to have, right, in the last row, essentially 0, 0, 0, 0, which tells me I have a line of intersection because I know that these are just scalar multiples of each other. So what does this tell me now? This gives me a relationship between my variables. This gives me a relationship between my variables that z is my free variable. It gives me a relationship between my variables that y is going to be equal to negative 3 plus z or plus z. And it gives me a relationship that x is going to be equal to 10 plus 5y minus 3z. But what is y? Negative 3 plus z, so that's going to be 10 plus 5 times negative 3 plus z, and minus 3z. So if I add all of that up, I have 10 plus 5 minus 5 times negative 3, so that's negative 5. 5 times positive z, that's 5z, minus 3, that's going to be plus 2z. So the equation of my line of intersection. Doesn't matter the approach that I use, it doesn't matter, but I should know how to get to my equation. And so I can say, hey, r is going to be equal to, easiest to give the vector form, and I've got negative 5 and negative 3 for my x and my y, so negative 5 and negative 3, 0 for the z, and the directionality. I have x has a factor of 2, y has a factor of 1, z is itself, so I have 2, 1, and 1. And that is the equation of the line of intersection. So a variety of ways that you can work through the problems. Obviously, that particular problem is a little bit easier if you know that you have a calculator. But we must be familiar with the matrix approaches. We must be familiar with elimination and substitution approaches. If you're good at one, use that, right? The matrix approach does tend to keep you more organized and allow you to be able to work with better facility on harder problems. So, with what you have done and what you have learned, be sure that you provide a summary and make sure you understand the relationship between intersections of planes and the intersections of lines with planes. Always be reflective. I appreciate your time. Please be sure to come back and get assistance as you need. Thank you very much.